All right, so now we're going to get into learning how to balance chemical equations now that you've copied your Q&A number 34 on counting atoms. So we discussed before about what is a chemical change. So in a chemical change, you make a new substance. Well, scientists use chemical reactions to describe these chemical changes. So you have a reactant, which is your starting substances, like your ingredients. When you're making using a recipe, you have your ingredients, and then your product is the substances that's being produced. So here are some evidences again about or indicators that a chemical reaction has taken place. You had a change in temperature, or you had an evolution of a gas, which means you saw some fizzing and bubbling, a formation of a solid, which is a precipitate had formed, a change in color. Now, energy changes in a chemical reaction can be either classified as exothermic, which is energy is being released, meaning going out, so the reaction gets warmer, endothermic, endo meaning going in, that means the energy is being absorbed and it feels cold. We'll talk more about those two types of energy changes a little later in another lesson. Now, there are some symbols that you need to be aware of. So you'll see this arrow in a chemical reaction or a chemical equation, which means it could mean yield, produces, or forms. Of course, you'll have plus signs on either side of your reaction. And then beside each compound, you might see a symbol that represents whether it's a solid with an S, a liquid with an L, a G with a gas, or dissolves in water, which you'll see AQ. And then you have just a recap. Remember, ionic means you have a chemical compound that's between a metal and a nonmetal, and molecular means you have two nonmetals. And then don't forget about our diatomics, and there are 7 of them, and they always appear in nature as 2. And you can remember Brinklenhoff, or you can just simply go by the little um, pattern that I showed you on the periodic table. So I didn't know if you actually saw this AQ. I saw it was being hidden. So AQ just means it's been dissolved in water. So let's continue on. Again, just can't forget that if we have two nonmetals, it is molecular, and we use prefixes like mono, di, tri, tetra in order to name them. If it's between a metal and a nonmetal, that's ionic. So we use our charges on the periodic table, the swap and drop, and to get your formulas. Now, what's up with these apples? Right, they're not balanced. You got 2 on this side, you got 3 on the other side. So now we have 3 on both sides. So now they are equal, or they are balanced. So chemical reactions, got to do the same thing. We've got to have 2 bromines on the left, 2 bromines on the right, 2 lithiums on the left, and 2 lithiums on the right. So when a chemical reaction is a process that leads to the transformation of one set of chemical substances to another. So the parts of a chemical reaction, we kind of mentioned that earlier. So 2 sides of a chemical equation, you have your reactant, which is on the left side of the arrow. See, here's our arrow that separates the left side from the right. And so the left side is called the reactant. Then you have your arrow, and then the right side of the arrow is called the product. If you can remember this little acronym, hang on, where you put the word R, A, P. So RAP, that will help you remember that the reactant's on the left and the product is on the right, and the A stands for the arrow, so RAP. So you'll never forget, because I will ask you which side is the product side, which side is the reactant side. Now, because we are balancing these equations is due to the law of conservation of mass. So mass cannot be created nor destroyed. So therefore, chemical reactions must be balanced. So the number of elements on the reactant side and the product side must be equal. So you have what we call subscripts. So don't forget, I want to make sure we know what those are called. These are your subscripts. So that means it has two oxygens. They cannot change. When you are starting to balance the equations, you cannot change your subscripts. And then coefficients is that big number that comes in front of the whole thing of the substance. So it can change. So you can change coefficients. In this example, there are two oxygen compounds, but because of that two, there's a total of 4. These are your steps in balancing chemical equations. You don't necessarily have to write these down. You can refer back to the notes. You can go to Unit 4 module, and they are posted there. But just we're going to be going through these steps. So you want to draw a line that will separate your product side and your reactant side. Then you want to count the number of atoms on each side. Then you will either add or change coefficients. And a little helpful hint, sometimes if you try to balance these, the oxygen and your hydrogen first, it's kind of hard to do. So that I would leave that to the end. And a lot of times they get balanced out by the time you get there. And then just check your work. But a good rule of thumb that you need to understand, subscripts can only be changed. Never change your subscripts, only your coefficients. So let's look at this first example. So I'm going to separate my left side from my right, and I'm going to write down the atoms that are in each side. So I have nitrogen and hydrogen on the left. I have nitrogen and hydrogen on the right. And I always make sure that I put them at the same, in the same order. In this case, they are already in the same order, but you'll find that that's not the case for a lot of them. All right, so you have a 2 after the nitrogen, so that means it has 2. You have a 2 after the hydrogen, so that means it's 2. And then over here, we see that nitrogen does not have a subscript, so that means it's 1. And then hydrogen has 3. So right off, we see that nitrogen is 2, and this nitrogen on this side is 1. So you see I have these lines in front. That means that's the only place I can put a number to make it balanced. So I'm going to, I need to figure out what number times 1 gives me 2. Well, that's a 2. So 2 times 1 nitrogen is 2. So I'm going to mark out my 1 and put a 2. But that also changes my hydrogen. So 2 times 3 hydrogen gives me 6. So now I come over here, my nitrogen on the left, my nitrogen on the right are equal, but now my hydrogens are unbalanced. So I need to put something here. So what number times 2 will give me 6, and that gives me a 3. So 3 times 2 gives me 6. So now we have a balanced equation. So you never, you don't have to put a number in the blanks, but sometimes as spacers, we'll just put a 1. But that means that's the same thing because 1 times 2 is still 2. All right, let's go to another example. And if you want, you can stop the video and you can try counting the atoms on your own and see what you can do, and then come back to the video and look at how to balance it. So we're going to put each element and how many atoms you have for each. So 1 and 1, 1 and 2. So hopefully you can see that neither one of these has a subscript, so that means they're 1. Iron, no subscript, 1. Oxygen with a 2. So right now my iron is looking good, but my oxygens aren't. So I've got to get this oxygen to equal to 2. So again, the only thing I can do, I can't put a subscript after the oxygen. The only thing I can do is put the coefficient that's in the front. So what times 1 gives me 2? Well, that's a 2. So 2 times 1 oxygen gives me 2. But it also changes my iron. 2 times 1 iron is 2. So now that tells me I've got to go over here and make this iron 2. So it's a 1 here, so I'm going to put a 2. So 2 times 1 is 2. So now we have another balanced equation. Now at this time, if we were in class, you would be working with a partner on a dry erase board. So you can stop the tape or the video and then do these problems on your own, and then you can restart the video in order to balance out the equations. All right, so this is what we have. This one's a little different, but I'm still gonna show you that we've got to separate the different elements. So nitrogen does not have a number, so that means it's 1. Oxygen doesn't have a number, that means it's 1, but we got this plus sign and we have another oxygen here. So we have 1 oxygen here plus we have 2 oxygens here. So 1 plus 2 gives us 3. All right, now nitrogen, just 1, and oxygen, 2. All right, so nitrogens are good, but our oxygens are unbalanced. Now, when you are balancing these equations, you have to balance them with the smallest number possible. So the coefficient 2 is our smallest number. So I'm going to try 2 here. And when I do that, of course, that changes my nitrogen. 2 times 1 nitrogen is 2. It also changes my oxygen. So 2 times 1 oxygen, that is now a 2 there. But I still have these 2 here. So 2 plus 2 gives me 4. All right, so now I go over here and I now have 2 nitrogens and only 1. So I'm going to put a 2 there. So 2 times 1 gives me 2. And then 2 times 2 gives me 4. So voila, you have a balanced equation. The next practice, these are all just real simple ones. They're going to get a little bit more involved. So we have 2 and 2, 1, 1. Oops, let's fix that. 1 and 1. So hopefully you've already done these and you're just checking your work. So hydrogen has 2, this hydrogen has 1. So I need this hydrogen to be 2, so I have to put a 2 there. So we got 2 times 1 is 2, but that also changes my chlorine. And remember, this is chlorine, not carbon and iodine. Chlorine, whenever you see that L, it's not a capital letter I after the C. It's always Cl, capital letter C, lowercase l. So 2 times 1 chlorine is 2. And there, you got it. So didn't have to put anything over here. Now I can put ones just as that nothing goes there. All right, the next one, Fe, Cl, Fe, and Cl. So we got 1 and 2, 1 and 3. So here we go. Our chlorines are unbalanced. Because chlorine is only on one side, only one place on this side, and chlorine's only on one place on this side, 2 and 3 are multiples of, 6. So we need to make those a 6. So what times 2 gives us 6? That gives us a 3. So 3 times 2 is 6. And then what times 3 gives us 6? That would be a 2. But it also changes my Fe to a 2. And now we have 6 chlorines. So now I've got to go back over here. Because this is a 2, we need to make this a 2. So I put my coefficient 2 there. And there we have it. And you'll soon learn, some of you will be able to do this without writing all this. This is not necessary. It just helps you make sure you don't make any mistakes. So in this case, we needed coefficients for all of those. All right, and then the next one, now we have 3 different elements. We've got carbon, hydrogen, oxygen. And I'm going to put them in the same order, carbon, hydrogen, oxygen. So here carbon is 1, hydrogen is 4, oxygen is 2. On this side, carbon is 1, hydrogen is 2. But let's be careful with our oxygen. We have 2 here, so I'm going to put a 2 up there. Plus, notice we have 1 more. So that's a total of 3. So let's look. We see that hydrogens are 4 and 2. So let's make this hydrogen a 4. So in order to do that, what times 2 gives us 4? So 2 times 2 is 4. Now for this oxygen, so don't say 2 times 3 because that you don't have 6 oxygens. You're going to count it up here. So we have a 2 here and there's 1 oxygen. 2 times 1 is 2. So now we have 2 on right here. So now we add 2 plus 2, that gives me 4. So now we've got 1 and 1, 4 and 4, and now 2 and 4. So we want to look at what times 2 gives us 4. And of course, a 2 goes there, and that gives me 4. So we could put our little ones here if we wanted to. All right, here's a couple of other examples. But as you can see, potassium is 1, that's okay. Chlorine is 2, chlorine is 1, so I could put a 2 here. And then that makes our potassium 2, so I'll put a 2 here. So try that one on your own to see if you can get that one. And then we have nitrogen is 2, nitrogen is 1. So I'm going to put a 2 here. Now my fluorines are 6. 2 times 3 is 6. So I'm going to put a 3 here. And 3 times 2 is 6. So there's your balanced equation. So what we're going to do next is I have a worksheet for you to do. And if you will work on that, and once you've done all those on that worksheet, if you'll find the answer key, I will have it posted and you can check your answers. Make sure in the text box you type any kind of questions that you may have.